Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam, whether you're targeting a grade 7 or pushing for a 9. Let's get into it.
Hook. This one slip-up on vector questions cost students more marks than almost any other line of working last year, mixing up position and direction and then treating them as the same thing. It looks small on the page, but those missing signs and swapped pairs are easy marks to drop. Stay with me for the next minute and I'll give you a simple check that catches those errors every time.
Promise. In this episode, we'll do 3 things. 1. I'll explain clearly what position and direction vectors actually mean and how components work. 2. We'll walk through a real GCSE-style question step by step with the exact lines of working examiners want. 3. You'll get a 10-second component check, a practical habit you can use in every vector question. That check will save you marks under exam pressure, I promise.
The concept. Start simple. A position vector tells you where a point is from the origin. If a point A is at 3, 2 on the grid, its position vector is written as 3, 2, or sometimes 3, 2. A direction vector tells you a displacement, how to get from one point to another. If you move 4 units right and 1 unit up, the direction vector is 4, 1. Think position equals address, direction equals instruction. Keep that image. It prevents mixing them up under time pressure.
Why do components behave like coordinates? Because a vector has 2 independent pieces of information, the x change and y change. On graph paper, those are just the horizontal and vertical steps. So when you add vectors, you add the x parts and the y parts separately. When you multiply a vector by a scalar, you scale both parts. That's why writing vectors as pairs, for example xy, is not just notation, it is the arithmetic you will use in every calculation. A quick visual. Imagine starting at the origin. The position vector 3, 2 points at the location 3, 2. From there, the direction vector 4, 1 moves you to 7, 3. So position plus direction gives a new position. Say that sentence to yourself before you write anything down. It keeps your working exam-friendly. Worked example. Here's a typical GCSE question. Points A, B and C have position vectors A equals 2, 1, B equals 5, 4 and C equals 8, 7. Show that B is the midpoint of AC and then show that A, B and a point D with position vector D equals 11, 10 are collinear. I'll write every line of working you should put on the paper. Step 1. Midpoint of AC. The midpoint is the average of the position vectors of A and C. So midpoint M equals A plus C divided by 2. Write that down. Compute A plus C equals 2 plus 8, 1 plus 7, equals 10, 8. Divide by 2 gives M equals 5, 4. That's exactly B, so B is the midpoint. On the paper, show A plus C equals 10, 8. Then M equals 5, 4. Therefore M equals B. That 2-line calculation gets you the midpoint mark. Step 2. Collinearity of A, B and D. A quick method is to form direction vectors AB and AD and check if one is a scalar multiple of the other. Compute AB equals B minus A equals 5 minus 2, 4 minus 1 equals 3, 3. Compute AD equals D minus A equals 11 minus 2, 10 minus 1 equals 9, 9. Notice AD equals 3 times AB, because 9, 9 equals 3, 3, 3. Therefore, A, B and D are collinear. Write each subtraction and then the scalar multiple step. Examiners want to see the ratio or the explicit multiple. Curious. Notice how neat the arithmetic is here. Identical components give a clear scalar. If the components had been 3 minus 3 and 9 minus 9,
It's the same idea. Keep track of signs. Small sign slips are the usual mark eaters.
The exam technique. Here's where the marks are. For the midpoint part, that's typically 2 marks. M1 for writing M equals A plus C divided by 2, and M1 for the correct numerical midpoint leading to the A answer mark. For the collinearity part, that's usually 3 marks. M1 for forming direction vectors, M1 for showing the scalar multiple relationship, and A1 conclusion that the points are collinear. If you can't finish, always write the direction vectors. That first M1 is a free partial mark.
Common mistakes that cost marks: not showing the subtraction when forming direction vectors, skipping the division by 2 when finding a midpoint, or cancelling terms without writing the intermediate pairs. The examiner can't award method marks for steps you don't show, so write down A plus C, then show the division by 2. Even if the numbers feel obvious, write it down, don't just think it.
The quick win, your 10-second component check. Whenever you finish a vector calculation, do these 3 fast checks. 1. Write vectors as pairs, x, y, and underline them. 2. Check ratios of corresponding components when testing collinearity. If x ratio equals y ratio, that's your scalar. 3. For midpoints, average component-wise and compare to the given point. Say it aloud: pairs, ratios, average, and use that checklist on every vector question. It takes 10 seconds and catches most careless errors.
Common pitfalls and teacher tip. Teachers, a quick classroom activity is to give students 3 random position vectors and ask them in pairs to identify midpoints and produce one vector that makes the 3 collinear. Time it for 5 minutes and then swap answers. For students, watch for these pitfalls: mixing up position and direction, forgetting negative signs, and cancelling without showing the pairwise arithmetic. A simple habit, write each subtraction and scalar multiple, avoids most of these.
That's your quick win for today. If this helped, share it with a friend who's revising. You'll find more worked solutions and revision resources at jcacademyonline.co.uk. Until next time, trust the process and nail that exam. Stay curious.